my name is Brandon Lopez. I'm a mechanical engineering major. I'm CAD designer, editor, and 3D printer for the Red Team IGV competition.
Hi, my name is Ethan Smith. I took the lead on the electrical and electronic subsystems of the robot, from the wiring to the programming. I also did a significant amount of work on the CAD designs.
Hi, I'm Jordan Hine. I'm a mechanical engineer for the Red Team, and I'm the mechanic and team lead.
Hey, my name is Abhimanyu. I'm part of Red Teams, and my major is mechanical engineering.
I'm Andrew Ramirez, and my major is mechanical engineering. My main roles were in component mounting, risk analysis, and part sourcing.
Hi, my name is Devin O'Neill. I'm a mechanical engineering student, and my primary focus for the project was on finite element analysis of our final design.
The purpose of this project is to design an intelligent ground-based system capable of navigating through a series of complex obstacles to participate in the UCF Intelligent Ground Vehicle competition. The primary challenges are to construct a vehicle with the capability to detect and avoid spot obstacles, traverse through a maze of linear barriers, and climb onto, then traverse on an uneven rubble-like surface, all while remaining within a budget of $350. The secondary challenges of this project are to have the vehicle complete the course as quickly as possible and to optimize the vehicular maneuvering and control.
The obstacle course set before us is designed to mimic real-life scenarios. These scenarios include assisting in disaster relief, navigating through buildings and hallways, and general autonomous navigation. The reason that this project is so important is due to its purpose of removing humans from potentially life-threatening situations.
When we created our engineering design specifications, we also outlined procedures for making sure we met those requirements. Now, before our competition, we intend to follow those procedures to ensure that we have met our goals. Additionally, we will need to test our code. We will do this first at home and on campus to test basic functions. Once those wrinkles are ironed out, we will test the vehicle's performance on the obstacle course itself. From there, we will be able to tweak what we need to get our vehicle to optimal performance. Since the robot is fully autonomous, the programming is extremely important. I'm going to go over some of the key features of the code. Since the computer we chose to power the robot is the Arduino Mega 2560 Rev 3, we are using the Arduino IDE and the C++ language. Now, for devices that the robot connects to, we have 10 ultrasonic distance sensors positioned around the robot to give us data on the position of obstacles. We have 6 motors that control the movement of the robot. An inertial measurement unit acts as a compass for the robot, so the robot always knows its heading. Additionally, we have 2 buttons and 19 LEDs. These allow us to interact with the robot if we need to, and the LEDs allow us to see what the robot is thinking. Now, in broad strokes, the robot's operation has 3 modes: obstacle avoidance, maze, and rubble. Rubble mode is very simple. The robot basically just drives at full speed. The obstacle avoidance mode has the robot go forward while avoiding obstacles in its path. In maze mode, the robot uses Pledge's algorithm to solve the maze. The robot uses sensors to determine which mode it should be in.
We would go into meetings every week with questions and ideas for our stakeholder, particularly our faculty advisor. The feedback was very helpful and important when implementing our ideas because we needed to follow specific guidelines for our competition in April. We used these guidelines as the first step to creating our vehicle, and we used the feedback of our advisor to supplement it. For example, using a wiring diagram just to make sure that our components are compatible with each other, or even just letting us know that some designs may be more risky than we had initially planned. Combining the feedback from our advisor and our own ideas, we were able to develop the best possible vehicle while also following the guidelines of the competition.
Zoom was a huge contributor to our team this past year. Although it wasn't the same as an in-person collaboration experience, it did allow for us to get the work we needed to completed. We were able to set up a group chat in Microsoft Teams as well, which has the functionality of creating different channels for different conversations and files, which served as a means of keeping our tasks organized. The team was also able to meet every week, where we discussed our objectives for that meeting and what we expected to have completed by the next one. We collectively feel that we each did our part to meet our internal deadlines and put in extra work when needed. Even though we weren't in the same room, we were still able to get the work done.
There was a disagreement at one point during the semester concerning the material makeup of our vehicle. One teammate argued for PVC pipe while the other argued for machined aluminum. Both had their selling points, but the PVC teammate argued that PVC pipe will be more cost effective. So, the PVC teammate built a mock-up of the vehicle using the PVC pipe to prove that it was possible. In the end, the team was content with PVC pipe as the base material, and we were able to tackle the next issue at hand.
Each member of the team was interested in the project since it was first presented to us. We all came to the table with different ideas for the design, which at first was overwhelming, but we eventually decided that a majority vote would take place at each crucial step in the design process, as well as any other major decisions that we needed to make in regard to the vehicle. We knew that there would be an abundance of ideas that had merit, but oftentimes only one could be employed in a particular situation. This led to pride in our efforts both individually and collectively towards our final product and the race that it will participate in, which kept us motivated to always try and meet our deadlines and stay on track towards the final goal.
The biggest lesson we learned throughout the project is the teamwork and how we are able to collaborate efficiently with each other with a quick period of time. From starting, our teams has a clear goals and has defined roles for each individual, which makes all of us to trust our teams and can be dependent on each other to complete the task on time. For complex problems, we divided into the parts and planned it accordingly. Furthermore, discussion and understanding each other help us to bring the best out of us. We have learned how to plan and manage times, which can be explained through our team examples. Scheduling of our teams, considering the schedules of our teams, we asked everyone their availabilities and managed their time to work on an assigned task based on their performance.
For the duration of this project, we collaborated constantly. No single one of us could have done the entire project by ourselves. Each teammate had their own strengths and area of expertise. For the most part, tasks were divided and distributed based on these strengths. In the few cases where no individual was confident enough to tackle a challenge on their own, several team members worked together to achieve the desired result. In the end, our organization, communication, and teamwork helped us reach completion, and we're very proud of the result.